In this tutorial, we'll focus on R and explore its core features, capabilities, and practical applications. This video will guide you through the fundamentals of R, including data manipulation, statistical analysis, and visualization techniques, helping you build a solid foundation for working with data effectively. In R, you can print the message hello to the console with a simple print statement. In R, there are several data types, including character strings, integers, and numeric values. For example, you can store a name such as John, an age such as 30, and a height such as 6.0 in variables. You can then use the print function to display these values in the console and verify that they have been stored correctly. After creating variables and printing their values, you can use the class function to identify the data type of each variable. Understanding data types is important because our processes different types of data in different ways. For example, a name such as John is stored as a character value, while age and height are typically stored as numeric values. By applying the class function to each variable, you can verify how R has classified the data and ensure that your variables are being stored in the expected format. This is especially useful when working with larger datasets, as it helps prevent errors and ensures that calculations and analyses are performed correctly. Another important data structure in R is the vector, which is used to store multiple values of the same data type in a single variable. For example, you can create a vector named scores containing the values 85, 90, 78, 92, and 99 using the C function. Once the vector is created, you can use the print function to display all the scores. You can also use the max function to find the highest score and the min function to find the lowest score in the vector. These functions make it easy to summarize and analyze numerical data stored in vectors. You can access individual elements of a vector using square brackets. Vector indexing starts at 1, so scores 1 returns the first value in the vector, while scores 3 returns the third value. This allows you to retrieve specific data points from a vector without displaying the entire set of values. Using indexing is especially useful when working with larger datasets, as it helps you quickly access and analyze particular elements within your data. Data frames are used to store data in a table-like structure, where each column can contain different types of information. For example, you can create a data frame called students that includes a column for names, ages, and scores. The names can be John, Bob, and Daniel. The ages can be 25, 23, and 29, and the scores can be 90, 98, and 99. After creating the data frame, you can use the print function to display the full data set in the console. This makes it easy to view and organize related information in rows and columns. You can access specific columns of a data frame using the $sign operator. For example, if you have a data frame called students, you can view the score column by using students $sign score. This will return all the values stored in the score column, allowing you to analyze or work with that specific data separately from the rest of the data frame. You can use the summary function to get a quick statistical overview of a data frame. For example, if your data frame is called students, you can run summary students to see a summary of each column. This will display useful information such as the minimum, maximum, mean, and quartiles for numeric variables, and counts for categorical variables. It is a helpful function for quickly understanding the structure and distribution of your data. You can calculate the average of a numeric column using the mean function. For example, if your data frame is called students, you can find the average score by using mean students $sign score. This will compute the mean value of all the scores in the score column. It is important to ensure the column name is written correctly, as R is case sensitive and will return an error if the name is misspelled. You can filter rows in a data frame based on a condition. For example, if you want to select only the students whose scores are greater than 88, you can use logical indexing like students $sign score 88. This will return only the rows where the condition is true, allowing you to focus on high-performing students. Filtering data like this is useful when you want to analyze specific subsets of a dataset. Let's go through a simple exercise in R using a data frame to understand how data is stored and analyzed. First, we create a data frame called products, which contains two columns, producer and price. The producer column includes the values A, B, C, D, and E, while the price column includes the values 10, 15, 12, 20, and 18. This structure allows us to organize related information in a clear, tabular format where each row represents a different product entry. Once the data frame is created, we can use the print function to display the entire dataset in the console. This helps us confirm that the data has been entered correctly and gives us a full view of the table. After reviewing the data, we can perform a simple statistical operation by calculating the average price of all products. To do this, we use the mean function on the price column by writing mean products $price. This function takes all the values in the price column, adds them together, and divides by the number of observations to return the mean value. This is a useful way to quickly summarize numerical data and understand general trends within a dataset. To summarize this section, R provides several fundamental tools for working with data efficiently. You can use the assignment operator to store values in variables, which helps you organize and reuse data throughout your code. To create collections of values, you use the C function to build vectors, which are one of the most basic data structures in R. For more structured, table-like data, you can use data frames, which allow you to organize information into rows and columns, making it easier to work with real-world datasets. Once your data is prepared, R provides several useful statistical functions for analysis. The mean function is used to calculate averages, while summary gives a quick overview of key statistics such as minimum, maximum, median, and quartiles. In addition, the max and min functions help you quickly identify the highest and lowest values in your data. Together, these tools form the foundation of basic data handling and analysis in R, allowing you to store, organize, and explore data effectively. In R, you can calculate grades using a custom function with conditional statements. For example, you can create a function called grade that takes a score as input and returns a letter grade based on the value. If the score is greater than or equal to 90, the function returns A. If the score is greater than or equal to 80, it returns B. Otherwise, it returns C. This type of logic is useful for categorizing numerical values into meaningful groups. Using functions like this helps automate decision-making processes in data analysis and makes your code more efficient and reusable. In R, you can define functions with multiple parameters to perform calculations. For example, you can create a function to calculate profit using revenue and cost as inputs. Profit is calculated as revenue minus cost. So, you can define a function that takes two parameters, such as revenue and cost, and returns the difference between them. For instance, if you call the function with the values like 1000 for revenue and 750 for cost, it will return a profit of 250. This approach is useful because it allows you to reuse the same function for different values without rewriting the calculation each time. In R, you can use an if-else statement to make decisions based on conditions. For example, you can create a variable called temperature 30 and then check its value using an if statement. If the temperature is greater than 25, the program will print hot. Otherwise, it will print cold. This type of conditional logic is useful for controlling the flow of a program and making it respond differently depending on the input values. It allows you to automate decisions based on data rather than writing separate code for each case. R, you can use a for loop to repeat actions multiple times. For example, if you want to print numbers from 1 to 5, you can use a loop that goes through the sequence 1, 5. In each iteration, the loop assigns the current value to a variable, such as I, and prints it using the print function. This is written as for I in 1, 5, print I. This type of loop is useful when you need to perform repetitive tasks. In R, a while loop is used to repeat a block of code as long as a condition is true. For example, you can create a variable count 1 and then use a while loop to print numbers from 1 to 5. The loop continues running while count equals 5. Inside the loop, you print the current value of count and then increase it by 1 using count plus 1. This is written as count 1 while count equals 5, print count plus 1. This type of loop is useful when you don't know in advance how many times you need to repeat a task, and you want the loop to continue until a condition is met. Throughout this video, you learned the basics of our programming, including variables, vectors, data frames, functions, conditional statements, and loops. You also explored how to perform simple data analysis using built-in functions like mean, summary, max, and min, as well as how to structure logic using if, else, for, and while loops. Keep practicing these concepts to strengthen your understanding of R and build more advanced data analysis skills.